Hello, everyone. Quadratic functions. You're going to see them a lot in math, in physics, like in projectile motion, in finance, in accounting, in chemistry. So in this video, we're going to analyze quadratic functions, basically parabolas, and help you understand them so you can apply them with confidence. All right, hello, everyone. Again, this video, we're going to explore quadratic functions and their characteristics, take several examples. Please like, subscribe, share on your social media. Let's begin. So the first thing that we need to talk about is finding the vertex for a quadratic function. Because quadratic functions, let's go back here a little bit. Quadratic functions, these are parabolas. Okay? And if we have a parabola, we need to find the vertex. We need to find certain properties of the parabola to help us understand it better. So finding the vertex of a quadratic function is extremely important. So first thing is we're given a quadratic function of this form, and we want to put it in this form called the vertex form. We've seen this back in completing the square. Okay, this a is the same as a. Once we put it in this form by completing the square, then automatically the vertex becomes h. We grab that number here, h. That becomes the x-coordinate of the vertex. K becomes the y-coordinate of the vertex. And the axis of symmetry is just x equals h. We'll talk about those in just a second. So this is method one to find the vertex of a parabola or a quadratic function. The second method is, again, we start with the same quadratic formula or some quadratic formula, but we do not change this. We do not put it in any other form. All we do is grab from the values a, b, and c the vertex, the x of the vertex and the y. This is the x of the vertex, and this is the y of the vertex. X is just negative b over 2a. So we get the b divided by 2a, and we put a negative in front. And whatever number we have here, we plug it in for x to get the y. And that's what that is, f of negative b over 2a. So this is the vertex, straight out, and the axis of symmetry obviously is negative b over 2a. Okay? But this doesn't change form. It just stays the same. So these are the two methods that we have that will allow us to analyze quadratic functions. So the graphs, again, of quadratic functions, as I mentioned earlier, are parabolas. This is a parabola. It has a vertex right here. The blue line is the axis of symmetry. Here is where it intersects the y-axis. We have a y-intercept. This one does not intersect the x-axis, so we have no x-intercepts. The parabola could open down. See, this one is opening up. This one can open down. The highest point right here is still the vertex, called the vertex. This is a vertex. That's a vertex. This is the axis of symmetry. Here it cuts the y-axis and two x-intercepts right there. Okay? So these are the two types of parabolas that we have. Let's look at this one here, and then let's just try to answer some of these questions. These are the properties of the parabola, okay? First of all, it opens up versus opening down. This is called concavity. How does the, is it concave up or concave down? This one is concave up, and when a parabola is concave up, means a is greater than 0, and vice versa. If a is greater than 0, then the parabola opens up. And if we see a parabola opening up, that means a is positive. This is the vertex right here, the points hk. The axis of symmetry is the blue line. Again, this is x equals h. The x-intercept, in this case, there is none. But we could have 1 or 2 or none, okay? Y-intercept is this point right here. This is 0 for x, y sub 0 for, okay? min or max, if we look at the parabola opening up, the vertex represents a minimum. Okay? It's the lowest point on the graph. The graph doesn't extend beyond that. Domain and range, if you recall, the domain is the allowed values of x. And in this case, this is a polynomial, okay, quadratic. There are no restrictions on x. X can take any value. So let's write it in interval form, from negative infinity to infinity. Now the range are the allowed values of y. And as you can see, y starts from here and goes up all the way to infinity. So this is the lowest point, and then the highest point is infinity. So for y, we can put a bracket right here because it could equal k. The lowest point is k, and then goes to infinity. And then use symmetry to obtain points on the parabola. So one point that's obvious that we can use the symmetry for is the y-intercept. So if there's a distance d here, we go another distance d this way, and this point sits on the parabola. Okay? And what else? That's it. And once we have these, we can plot the parabola. Now, if the parabola is concave down, that means the coefficient of x squared, a, is less than 0, is negative, and vice versa. If a is less than 0, then our parabola will open down. The vertex is right here, hk. So this is hk, whatever hk are, this will be the vertex. The axis of symmetry, this is still x equals h. X-intercepts, here we have two of them. Okay, two x-intercepts. The y-intercept, we always have a y-intercept. 0, y, 0. That's the y-intercept. Now, min or max. If you look at this parabola, do we have a min on the parabola or a max on the parabola? Obviously, here, these continue going to negative infinity. But we cannot go up beyond this point, beyond the vertex. So the vertex represents the maximum of the parabola. It doesn't go up above that, okay? So the domain and the range now, the domain stays the same because, again, we're still dealing with a polynomial, and the range is from, domain is from negative infinity to infinity. However, the range, it starts, again, it goes from here, from k, this is k right here, all the way down to infinity. And the way we write things in interval notation, we start with the smallest to the largest, like negative infinity to infinity. So here, this function is going all the way to infinity. So we start with negative infinity, and we increase until we get to k, but we can also equal k. Use symmetry to obtain points on the parabola. Again, we can use the y-intercept. This distance here is actually h. We can go another h over, and we get this point, and we can find the that point, and we can plot the parabola through it. And now we have several points. We can easily graph the parabola by hand. Okay. So let's see. Let's analyze this one. Okay. And here we are going to adopt one method from the previous section or the previous video about completing the square. Okay. So we are going to adopt well, we're gonna do two methods, but for method one, for completing the square, we're gonna approach it in a very, very standard way. Okay. So let's go ahead and do this. So first of all, we do completion the square or method one. And if you recall method one, we take y equals ax squared plus bx plus c, and we write it as ax minus h squared plus k. h in this case is negative b over 2a, and k is the function evaluated at h. That's one way. And the other way is this. Either way you want to do it is fine. I'm going to choose this method. Okay. It's pretty straightforward, but you could use that one. Okay. So let's go ahead and evaluate h and k and stick them in there. Okay. So h is negative b over 2a. Well, what are b and a and c here? Let's identify them. Okay, so here, let me just squeeze it in here. A equals 2, b equals 4, c equals negative 6. So h is negative b over 2a, that's negative. B is 4 over 2 times 2, and that's going to give me a negative 1. All right? So that's h. Now, k is again the function evaluated at negative 1, or 2 times negative 1 squared plus 4 times negative 1 minus 6. This is 2 minus 4 minus 6. That's negative 8. Okay? Now you could have done, if you remember this formula, it's the same way. B squared minus 4ac over 4a. B squared, b in this case is 4, so that's 16 minus 4. A is 2, c is negative 6 over 4 times 2. Okay? So negative 16. What do we have here? Here we have this is negative, this is plus 4 times 2 is 8, and 6 is 48. So that is plus 48, right? The two negatives mean a plus over 8, or negative 64 over 8, or negative 8. Gives you the same thing. Okay? So either way, it works. So we have k and we have h. So now we can write the parabola. We can keep it like this, or we can write it in its y equals a, which is 2, x minus 1 squared minus 8. Okay? And obviously the vertex is hk. Let's simplify this. The vertex is hk. Our h was negative 1 and k was negative 8. All right. So now we can find some other properties of the parabola. Okay. Now let's first find the intercepts. Those require computation. So let's look at the y-intercept. Y-intercept, that means we set x to be 0. So we have f of 0 is 2 times 0 squared plus 4 times 0 minus 6. So that's negative 6. So the y-intercept is going to be 0 for x, negative 6 for y. How about x-intercept? That's when we set y to be 0. So now we have two options. We could work with this directly, try to factor out, use quadratic formula, or what have you, but this is easier to work with, okay? This is easier to work with because x is already isolated by itself. We don't have many x's, we just have one x. Here, we have two of them. We might want to combine them, quadratic, factoring, what have you. So let's use this one here. 0, basically, or we can set this to 0. 2 times x plus 1 squared minus 8 is 0. Bring the negative 8 over. Becomes an 8. Divide by 2. We get x plus 1 squared equals 4. And now we take the square root of both sides. When we do that, we get x plus 1 is plus or minus the square root of 4 or plus or minus 2. So we have two values for x. So let me bring the 1 over. So x1 is the negative 1 plus 2 or 1, and the x2 is negative 1, negative 2 or negative 3. Okay? One time we take the negative here, and the other time we take the positive. We have to add it to the negative 1. So I have two x-intercepts, and they are 1, 0 and negative 3, 0. So we got the x-intercepts, we got the y-intercepts. Now we can answer everything about the parabola. Okay? So let's see what we can answer. Concavity. A is positive. So here A is greater than 0, or let's be specific. A equals 2, which is greater than 0. Then the parabola opens up. So it's concave up. Okay? The vertex, we computed it's negative 1, negative 8. Let's draw it. So this is negative 1. 1, 2, 3, 4, 5, 6, 7, 8, right here. So this is negative 1, negative 8. Okay. How about the x-intercepts? We said they were axis of symmetry. So this is the axis of symmetry. X equals negative 1. Intercepts x, we have two of them. We have one at 1. We have at negative 3. Okay. And we can see that they are symmetric with respect to the vertical line x equal negative 1. There are two squares from here to there, two squares from here to there. That means we're on the right track, okay, so far. So this is 1, 0, negative 3, 0. Y-intercept. Y-intercept was 6, right? A negative 6. So 1, 2, 3, 4, 5, 6, right here. This is 0, negative 6, the y-intercept. Now, here's the vertex. The parabola is going to open up. So what does that make the vertex? That makes the vertex the min. So we have a minimum on the parabola. We don't have a maximum, but we have a minimum because it keeps going up to infinity. Okay. Domain and range. Well, the domain again is always negative infinity to infinity. But the range in this case, we start from the negative 8 of the vertex, so we put a square, and it goes all the way to infinity. Let's take another point on the parabola. So right here, we have a distance of 1. If we go over here, in other words, when we're at negative 2, negative 6, we have another point. That's use of symmetry. Okay? And now we can plot the parabola. Let's see. So it has to go through that. Then comes down and goes up like this. There's your parabola. Okay, so we have everything we need to know about this parabola. Okay, or about this quadratic function. Let's look at this example. And again, the first thing we need to find is the vertex. Now we could use the first method there. Let's try using the second method just so that we can be, versatile in which method you want to use. So identifying things, a equals negative 1. So automatically your mind is saying, oh, the parabola is going to open down, right? Because a is negative. B is negative 2 and C equals 3. All right. So now what can we do? Let's first find the vertex. So the vertex is at negative b over 2a, f negative b over 2a. So let's find the x-coordinate of the vertex. Let's call this x sub v, y sub v for the vertex. X sub v equals negative b over 2a, negative b. b is negative 2 over 2a, 2 times negative 1. We have three negatives, so we're going to have an overall negative. 2 over 2 times 1, or 2 over 2 is 1. So the x is also negative 1. Let's go ahead now and plug in y, basically. Vertex is basically the function at negative 1. So negative 1 squared minus 2 times negative 1 plus 3. This is negative 1 plus 2 plus 3, and this is 4. So now, therefore, the vertex is at negative 1, 4, and the parabola opens down. Okay, so we should expect a maximum at the vertex. Okay, let's find the intercepts. Let's go here and find the y-intercept. That's easy. That's when we set x equals 0. So f of 0 is negative 0 squared minus 2 times 0 plus 3, and I'm going to get a 3 for that. So the y-intercept is 0 plus 3. Okay? Let's look now for x-intercepts. X-intercepts, oh, I don't have room here, so let me see if we can work it out here. So y equals, that's when we set y to 0. So x-intercepts, y is 0. So we set this to 0, negative x squared minus 2x plus 3 is 0. Multiply everything by a negative. That means becomes x squared plus 2x minus 3 is 0. Let's take it up here. We can factor this out. X minus 1, x plus 2 equals 0. Right? Sorry, 3. X plus 3 equals 0. Which means x equals 1 or x equals negative 3. So now the x-intercepts are 1, 0, and negative 3, 0. Okay? So we found the x-intercepts. We found the y-intercepts. Now we can go ahead and answer the questions about the parabola. So the concavity, a equals negative 1 less than 0, then it opens down. It's concave down. Vertex is negative 1, 4. What was it? Negative 1, 4. So negative 1. Let me make every 2 units in the axis 1. Negative 1, 1, 2, 3, 4. Here we go. This is negative 1, 4. And the axis of symmetry is x equals negative 1. Now, obviously, the parabola, even if we didn't know it opened down, we'll see that in just a second. This is x equals negative 1. X-intercepts. We said there was 1. This is 1. This is 2. This is 3. There's one x-intercept here. There's one x-intercept there. So if this is the vertex right here, if this is the vertex of the parabola, and the parabola has to go through these 2 points because they are the x-intercepts. And by the way, the y-intercept is right here also. This is 0, 3. This was 1, 0, and 3, 0. It has to open down. There is no way it cannot open down. A parabola that opens up doesn't go through any of these 2 or 3 points. So the parabola opens down. Min or max? Because the parabola opens down, the vertex is going to be the max. Max at the vertex. Okay? Domain and range. Domain, again, is still the same because we're still dealing with a parabola and we're still dealing with a polynomial. But now the range will start at negative infinity and go all the way up to k. K is 4 with a bracket, square bracket. Okay. Use symmetry, so we can go here and find another point on the parabola, and we can just plot it like this, make it look nice, and here's the parabola going down. And we have everything we need to know about the parabola. And this point here is negative 2, 3. Okay. There it is. Now here we are given equations, and we're asked to plot the parabola basically and say something about its properties. But what if we are given this or something like this? Can we get the equation that led us to this? Well, let's see. We know the vertex is at negative 5, 5, and there is this point, and the parabola is negative 8, negative 4. So let's see if we can get the equation of the parabola from that. So again, the vertex is at negative 5, 5. This is HK right away. And then there's a point on the parabola is negative 8, 4. So x0, y0. This is on the parabola, and that's negative 8, negative 4. And this is where actually putting it in vertex form is an advantage, because we write y equals a x minus h squared plus k. All we got to do now is plug in h and k in there. Again, h is negative 5. Plus 5, or a times x plus 5 squared plus 5. That's great. We're almost done. Now we need to get a. And just from the look of the graph, a is going to be negative. So if we get a positive a, we made a mistake. Let's go ahead now and solve a. How do we solve for a? We are given the parabola goes through this point right here. Which means if I plug x and y into this equation, the equality must be satisfied. The equality will hold. This is a point on the parabola. So if y is negative 4, a is negative, x is negative 8, okay? So here we plug x0, y0 into the equation. Huh? All right, bring this over. So negative 4 minus 5 equals a. Here we have a negative 3 squared. This is negative 9. Negative 3 squared is 9, so that's 9a. This implies a equals negative 9 over 9, or negative 1. And we got it. So now y equals negative 1, or negative a, right here from this equation, x plus 5 squared plus 5. Now we can expand this to get a full quadratic formula. Negative. Here we have a square of this, so we square the first. This times 2, so that's 10 x. Then square that plus 5. So that's negative x squared, negative 10x, negative 25 plus 5. This 2 gives me negative 20, and this is the formula for my quadratic formula. And again, we can check real quick, just so we didn't make a mistake in the math. If I plug in negative 4 in here, I should get a negative 8n. Oh, sorry, negative 8n for x. I should get a negative 4 for y. Okay? So we could do it. So if I plug in negative 8, so it'll be negative 8 squared minus 10 times negative 8 minus 20. This is 64 with a minus, that's negative 64, plus 80 minus 20. Well, negative 64 and negative 20 is negative 84, plus 80 is negative 4, and that checks out perfectly. Okay? So here we need to find the equation of a parabola that has this vertex and this y-intercept. They didn't give us a plot, they just gave it to us in words. So here's a parabola at negative 2, 7. So here's 1, here's 2, 7, 1, 2, 3, 4, 5, 6, 7. So I'm going to take two units in the x to make 1. So here's the vertex, and the intercept is negative 1. So it's over here. So we know the parabola is going to open down. That's the only way it can go through that intercept. And it's going to cut the x-axis at 2 points. So first of all, this is the axis of symmetry. And I am 2 units away from this, so I can make 1, 2 over here. So this becomes negative 4, negative 3. That's negative 2, 7. So the parabola has to go through this point, and it's going to be opening down. So whenever we get A, it has to be negative. So again, it's the same thing as in the previous example. Y, let's throw it right here, A, x minus h squared plus k. A, h is negative 2, so x minus negative 2 squared plus 7. K is 7. Work on these, is x plus 2 squared plus 7. Well, now I'm good except for A. I use the y-intercept, and this y-intercept is 0x negative 1y. So if I plug this into, so plug 0, negative 1 into the equation to get A. Because this is on the parabola, so it must satisfy this equation. So negative 1 for y, 0 for x. Bring the 7 over. So negative 1, negative 7 equals 2 squared is 4. That's 4a. That's negative 8 over 4 is a, which is negative 2. So now my equation is y equals negative 2x plus 2 squared plus 7. And we can expand it out. We can go ahead and basically negative 2. This is x squared. This times 2, that's 4x. Then square this one. Here we go. Negative 2x squared. Negative 2 times 4 is negative 8x. Negative 2 times 4 is negative 8 plus 7. That's negative 1. Okay? And automatically you would see if I plug x equals 0, which is what the y-intercept is, I'll get a negative 1 for the y-intercept. So this one checks out nicely. Okay? And the parabola will go something like this. We just need to get the x-intercepts to make it more legit. But they just asked us for the equation, and this is the equation. All right? So this is it for this video. In the next video, we're going to do word problems, quadratic equations that involve word problems. Okay? And again, if you have any comments, any suggestions, please drop them in the comments, and hope to see you in the next video and all future videos. Goodbye.